Alrighty. Thank you very much. Right, so what are we doing here today? I'd like to talk to you about Adscale a little bit, Adscale and its experiences on the Amazon AWS cloud. I do realise that many other cloud technologies are available. I'm going to kind of preface all of this with, by and large, our experiences purely with Amazon AWS, primarily because of the range and breadth of their features and the speed with which they're developing. I don't want to give them too glowing a report, but the reality is that my feeling is that they're well ahead in the game at the moment. So you can read into that, read into all of this that Amazon is kind of our primary choice here. So we're going to start with what Adscale Labs is, just so that you get a bit better of an idea of why we're looking at the cloud, and then you've already heard from Don that we're an agile software development house and that we're writing a German online advertising marketplace. We're putting adverts on websites. It's a fairly simple sounding idea, but the challenges that it leads to are interesting and widespread. We encounter every issue known to computing, I think. There is all sorts of memory management, network load issues, big data, and speed. We need fast response. We do 300 million ads every day to around about 40 million unique users every month. That is pretty much 80% of the German internet market. And we're pretty proud of that. That actually peaked us slightly over Google for a short period of time in the German market, and for a short time in about 2009, 2010. Currently though, we're sitting second to Google only, and again, we're pretty proud of that too, because Google is a behemoth. In this space, there is no one touching them. So to be second is almost to be first in one respect. But perhaps the thing that I am more surprised at and proud of in our involvement on the internet is we are ranked in the top 1,000 websites worldwide. Any website, anywhere in the world. We are currently putting it at around about 721. We've peaked at around about 580. This Alexa ranking is based on more or less the statistics you're seeing just above there. The number of transactions you're pushing through each day across the reach, the number of users. That complexity that you get, the quadratic complexity you get when you're trying to push that many transactions with that many users is something that is very, very difficult to solve, and we're doing it pretty well. So we're very, very proud of ourselves on that. So why are we using the cloud? It's almost a little bit obvious, given that if you're looking at that kind of scale, you probably almost get the answer straight out of it. But we actually have three major components that lead to our cloud usage. First is service delivery, so basically delivering the adverts. I'm going to preface all of my content on the service delivery around the fact that we, by admitting we're not actually doing it yet, but it is very, very high on our agenda at the moment, very close to implementation, but you'll see more about that soon. We're also doing a fair chunk of big data. I'll go into the big data chunk later on, but I think we're kind of on the low end of big data, but we're certainly kind of into that range. And also a dev test environment. I mentioned we're an Agile Scrum development house. We're doing Scrum, 3-week sprints, pushing code out every 3 weeks, and that gives us some interesting challenges in our development and test. And I'm going to finish up with a little bit about what we've learned over our 6-year journey so far. So let's just jump into service delivery and the issue of putting adverts on websites. I already mentioned 300 million adverts a day, but that is just the ads that we deliver. To do that, we do 3 billion transactions a day. We're passing information back and forth. We're finding out as much as we possibly can about people to make sure that they get the very best ad, the one that they're most interested in. And let's face it, I think most people that don't like internet advertising don't like the ads that they don't want to see. They probably don't see most of the ads. The ones that they do want to see, they probably are actually not too upset about. So we get the right ad, we get a reasonably happy customer base, and we definitely get a happy advertiser-publisher relationship. To deliver 3 billion transactions a day, we're doing around about 30,000 transactions a peak at the per second at our peak. Now that, I'm going to show you some graphs shortly, but that'll make more sense of that statistic. Every transaction we've got to turn around in around about less than 5 milliseconds. So we've got to be fast, and certainly our Alexa ranking shows that we are. It's part of the data that they will hold on us. We pretty much keep to that. And this is what I was talking about with our transactions per second. So one of our challenges is to deal with, I'm just going to see if I can find my pointer here, is to deal with these peaks here. This is a 24-hour period. And you can see here that our peak on a daily basis hits around about 7 to 8 times our trough. In a matter of 12 hours, we will shift to 7 to 8-fold of our traffic. And that causes a significant challenge, and actually is almost the answer to why I'm the CFO at Adscale as well as the SysOp. One of our big challenges here is to make this whole business cost effective. Again, something that we are in our development process, and what we're providing to the market, something that we're extremely good at. And one of the things that we managed to do is to deliver these 30,000 transactions per second, this 3 billion transactions a day, in a relatively small amount of hardware. I say relatively, but our costs are escalating right now because we're bringing in features at the moment that are causing even more complexity, and I'll try and describe some of them later if I don't run out of time, but I know we're getting a little bit squeezed. So basically, if we want to deliver that kind of transaction per second on this day here, and we're doing this in a traditional data center with rented hardware, you don't rent hardware by the hour in a traditional data center, you do it by the year, probably the 3-year period. And so when you go in with your hardware level based on the red line here, to absorb this peak for the day, you're actually going to be delivering the same transactions per second, the same amount of hardware is going to be used 12 hours later when you're sitting on a trough down here. Now some systems will allow you to perhaps cross-utilise the hardware that you've got dedicated to this particular service and maybe do other tasks in these downtimes. The reality is that the complexity of what we're dealing with is far outweighed, and we're better to just dedicate hardware to delivering this stuff all the time. So our hardware level sits up here all day, every day, for a period of a year. It'd be really nice if I could press the button, and if we could follow that line much more closely. And that's exactly what you can do when you're renting hardware through EC2. What you save here is everything between the red line and the dotted line. But it doesn't stop there, because I've already told you that we're doing 30,000 impressions a second, but this graph is only showing 14 and a half max. That's because this graph was taken about 2 weeks ago in the middle of the German summer when everyone's on holiday. That's what our peak transactions looks like over a yearly basis. If I was to deliver, as I said, we're renting this hardware on a yearly basis. If I'm to put in my hardware based on my August figures, by the time I get to December, I'm screwed. I need the green line, which is approximately twice the amount of hardware available for the red line. So if I now look at my delivery in August, I'm provisioning something like 10 times the amount of hardware I need at my troughs, which happen every day, just because I need it at Christmas time when our big peaks hit. So there is a very compelling argument here to shift to renting this stuff on the hour. But I've already said we're not doing it yet. Why are we not doing it? The reality is that co-tenancy and all of the nice stuff that you hear about AWS, it comes with co-tenancy, and co-tenancy makes things very messy. Virtualization isn't where you would like to think it is. You're not going to get the same performance out of your co-tenanted hardware as you are out of the stuff that, you're not going to get the same performance as you are out of your data center as you are out of your co-tenanted hardware. So we must be cloud ready before we do this. And what does cloud ready mean? It means that first up, our application needs to handle slower resources, being able to run on slightly worse networking systems and also struggle on the hardware side of things. I think John Daniel mentioned in his last presentation here, dealing with I/O on co-tenanted hardware is a nightmare, and that's certainly our experience as well. You need to be able to fail cleanly. You need to be able to run Chaos Monkey. Netflix is one of the biggest AWS customers. These guys are actually bigger than Amazon themselves. They're the book depository. And they are responsible, I think I heard at the Amazon conference last year, Netflix are responsible for something like 30% of internet traffic during prime time in the US. That's a hell of a lot of traffic, and they're doing it all through EC2. And all that time, they're running Chaos Monkey. Chaos Monkey runs around their network and randomly shuts down one of their production servers. You know you're ready to go onto the cloud when you can do that. Now, I don't want to do that in my own nice, clean, pristine data center at the moment, and I'm definitely not going to be doing it out there. There is a wee way to go. We're not that far off. We're certainly preparing for it, because you cannot deny those numbers there. That is a lot of saving in hardware. And ultimately you're talking around about between 50 and 80% cost savings on your hardware, if you've got a usage profile like that, as we do. Chaos Monkey, I really like that. That's one of my favourite pieces of software I've heard about in the last couple of years. So the next thing that we'd like to go on to is big data, Adscale's usage of big data and what we're doing with it. At the moment we're kind of generating around about 250 gigs of uncompressed data every day. This is in structured or semi-structured CSV format. Structured is using basically our own IDs to reference directly back into our models. It's either integers or date stamps, effectively. Semi-structured is the broader stuff that we may be using for targeting type stuff, things like the things that we'll find in HTTP headers that'll be user agent material or request references where we've seen this traffic coming from. Obviously, it's much wider, it's string-based, and we're a little bit random where we're going to with that. Unstructured, I imagine, is what the guys at Wynyard are dealing with, which is basically anything else. It could be a web page, it could be a piece of content, or it could even get down to binary data. So we don't have to deal with that, thankfully, at the moment. But one of the things that we're doing is keeping everything we possibly can, because we can, and we can because storage is unlimited. Now, this is the thing that has changed almost as a binary switch with our thinking. Prior to this, we spent a considerable amount of time and effort thinking about what we could save, when we could save it, and for how long we could save it for. Now we keep it, and we keep it for as long as we like. It just keeps on growing. Storage is truly cheap at last. Talk about your 1, 10, 15 terabyte disks sitting in or SAN storage sitting in a data center. As soon as you start getting into those things in a clean data center, you're really paying premium dollar. It's not the same as your 1 gig disk in a laptop. S3 storage is truly cheap. It's slow, but it'll keep it and keep it forever. And it changes the way you think about your data and what you're going to do with it. and we're just dumping it in S3. What are we going to do with it? Now, what's really, really important when we start looking at big data is how to deal with it. It's very, very tempting. Certainly, our first couple of attempts at what we were going to do is, with the data that we were receiving on transaction level, is to merge one or two or even all three of these steps. Now, what I'm talking about here is generation of data basically means we've received a transaction. Transformation is the aggregation or the accumulation or the analytical step of your data, and storage is more or less the compressed data, the aggregated data, and where you're going to keep it. That storage is still big enough. We're keeping kind of a couple of 100,000 rows of records of compressed data every day at the moment. But what we fell into the trap of very early on was a habit of trying to generate this data, transform it, and store it all in one or maybe two steps. Do not do that. Generate it, dump it somewhere you can get back to it, and then transform it. Now, do this for two reasons. First up, if you try and generate it, transform it, and store it all in one step, you're going to tie yourself in a knot, and you're going to couple up where you should be decoupling. Do not do it for a technical reason. It's very, very hard, and it's very easy to get yourself into scaling issues very, very quickly. But far more importantly is in that transformation step is where you're going to find your next business advantage. That is the step that's going to give you access, the analytics that you can do on that data, the stuff where you can find where data intersects, the clustering stuff that we saw in the Wynyard presentation earlier on, is exactly what you can find in the transform step. If you bypass that, you've got one transform, it's built into your system and you're storing immediately, you're going to miss that opportunity. Once it's gone, once that transaction is processed and thrown away, you're never getting it back. Generate it, keep it, transform it later, and then store the results in the form that you want it. Another thing you're going to find very, very quickly when you get onto this, the cloud and you start talking big data is that this is the fastest growing area, I think, in computing at the moment. It's obvious everyone is realising the potential of that transform step I was talking about previously, and what you're going to find as soon as you start looking is that everyone has solved it. Everyone's got the solution, you won't need to look elsewhere. Of course, that's bollocks. These are fantastic applications, these are fantastic products, all of them. We're using bits and pieces of all of these, but that's the reality. You are going to be using bits and pieces of all of these. As soon as you hit a problem that's basically bigger than one machine can hold in memory, you're going to find yourself bouncing around in any of these, and probably a combination of all of them. Just to give you a bit of a heads up on some of the real winners there. If you haven't come across Vertica and you're storing, John Daniel before was mentioning dealing with 300 gig in a MySQL database. Have a look at Vertica. It's going to save your life, I think. Another one is Vertica. Oh, geez, what have I done there, mate? There we go. It's a column-based data store, if you're interested. And the other ones are kind of a combination of Couchbase. I think is a fantastic product. It's key value store. We're using it heavily in our delivery and transaction generation, but it's also got enormous possibilities in the latest versions for JSON management as well. So very, very interesting products. But like I said, it's a combination of all of them, and you're really treading on new ground here. It's fun in a way, but it's also a bitch. This is actually a quote from one of our developers working on this stuff right now from last week. He's sitting there banging away on a Hadoop cluster or Elastic MapReduce cluster from Amazon. 4 hours later, chewing through about 250 gigs worth of data, and it crashes on him. So he's starting again from scratch, and you're going to get that. It's going to hurt for a while, but the benefits are there and the money is there too. So just moving on to the last little bit of the presentation. How are we going for time here, guys? I'll just... Oh, okay, sweet. That's good. Okay, so development test environment. I've always mentioned that we're an agile Scrum environment. Scrum means lots of change. We've got basically every 3 weeks, we've got new applications, and I'm guessing that a fair chunk of you are developers or you know developers, and therefore you know that developers don't know that machines have finite resources, that you cannot run another application and another application and another application. I'm actually pointing at Jason right now, who's right up the back there. We get these guys coming through with application after application, and the reality is that we do need them. We need to move fast. We actually need, I was mentioning to these guys down here before, in our industry we move extraordinarily quickly, and Agile and Scrum are essential for our survival. Something like, you could probably say between 40 and 50% of the products that we built in the first couple of years are no longer anywhere near, they're almost obsolete if not completely obsolete. The products that we've built in the last year are now generating between 50 and 70% of our revenue, and that is because we are turning these things around very, very quickly in order to not get bound up into too many legacy issues. We find ourselves building new applications but supporting older redundant ones, which we managed to shift aside. But in order to support all of this, our dev test environment, which used to run on around about 5 servers over in a Snap Colo suite, the reality is that we can't do that anymore. Those 5 machines probably work harder than any of our production machines when we go for a release on our 3rd week in the sprint. We need something that can grow and shrink flexibly. We need something that's got hardware flexibility, service flexibility, it's easy to set up, and it's easy to tear down. And it's all sounding like the cloud again. So we've basically got a small cluster at the moment. We're that close to running our first kind of production test environments, tests on it, and it's looking extremely good. We can set what takes us around about 4 hours to set the stuff up in our production test environment currently on our 5 servers is going to take us about an hour, and that's commissioning it to something like 4 times as many machines, which in reality is what we need now. So we need that flexibility, and pretty much the cloud is the only thing that's going to give it to us for anything like a cost-effective solution. It's cheaper and more flexible than owning or hosting this stuff ourselves. So very quickly going through what we have learned in our experiences on the cloud. First up, you're going to make a lot of mistakes. You're going to spend time and money trying to figure out what the best solutions are, especially when you get into big data, but you're also going to do it when you get out into the elastic compute stuff and you're trying to grow 10 or 15 cluster. You're going to find out all of a sudden that those IOPS, high IOPS servers that you thought you needed because you're coming from a clean data center actually cost you about 5 times as much as just a bog standard machine out of the box. You need to think in the cloud in order to make the money back, but you're going to make mistakes trying to figure that out. Start looking at the APIs early, because you're going to want to automate this stuff. It's as soon as you get into, especially building the test environments that we're talking about, you're going to want to tear this stuff, put this stuff up and tear it down, and you don't want to be doing that through the GUI. It's going to take you too long and you'll lose your head. Already referred to it, choose cloud-ready applications, choose stuff that knows how to fail, knows how to cleanly fail. It's good engineering anyway, and it's something that you're going to need because it will fail. Those boxes will just drop off on you. You're probably going to want a DevOps, unfortunately, because DevOps, as we know, are the hellborn spawn of a developer and a sysop, and are hated by everyone. But in this space, they're pretty well essential. You're going to want somebody who understands the system layer stuff enough about the application layer stuff to be able to deal with the complexity of the stuff that you're dealing with. already said it'll cost you time and money, and get help. And that's partly why I'm here today as well, is it's something that we as Adscale, I've already mentioned, we're owned by a German company. All of our business is in Germany. One of the reasons that we're here, and one of the things that we do on a regular basis, is to try and connect with the local software community, because it's one of the few connections that we can make legitimately. We have got a lot of experience in this, and we're running some pretty interesting stuff at the moment. So if you're into this space, if you're getting anywhere near it, give us a call, and we're happy to just sit down, have a coffee, maybe a beer if it's past midday, and and just sit down and talk about stuff. Maybe show you some of the stuff we're doing. We're not shy, and yeah, get on to us. We're in the phone book. Thank you.